Hi algebra students, this is our introduction video for our lesson on equations and their graphs. We're going to be continuing the conversation we started yesterday where we talked about solutions to equations and how they connect to graphs. For this introduction video, we're using this story here about a Little League baseball team. They're ordering hats. Each hat is the same price, and they also have to pay for shipping for the order. The graph below, right here, shows the total cost depending on the number of hats ordered. And then we're also given the equation y equals 14x plus 36 to represent this situation as well. The first question we're going to talk through is what is the cost of 9 hats? Go ahead and see if you can figure out what that cost would be. There's two ways we can figure this out because they've given us two things. We have an equation and a graph. If I wanted to use the graph to help me find the cost of 9 hats, I'm going to find 9 hats on our graph. That's at the 9 right here. And then if I go up to the line, the point on the line is going to help show that total cost. So it looks like the point is right here. And if I come over, it looks like it's at around 160. Now, because this graph is counting by 20s on that y-axis, it's hard for me to know if that's exactly at 160, right? That point could be at 160, 161. It's hard because the scale is so much larger. So this is why it's helpful that we've got this equation here as well. They've given me 9 hats. So that means in my equation, 9 is the number of hats. That's going to represent my x. And if I want to know the cost represents our y. And so this is all about substitution. I could take our equation, y equals 14x plus 36, and I need to substitute 9 for our x, since 9 is the number of hats. That means in my equation, I'm taking out the x, not 14, just the x, and I am replacing it with the number of hats. I am replacing it with the number 9. And because 14x means multiplication, it's going to say 14 times 9. The rest of this is just doing the math. So I could say y equals 14 times 9. 14 times 9 is going to be 126. And then 126 plus 36, that is going to give me 162. And so what is the cost of 9 hats? They cost $162. So going back to our graph, we had talked about this point right here would tell me that total cost, but it's hard from this graph to see, is that 160? Nope, it turns out it was 162. The next question is, what does the point 150 mean in this situation? I'm going to do the same thing we just did a moment ago. The 1 in this point represents our x, and the 50 represents our y. And so the question's asking about what that means in the situation. That means I should be using words from the story. If 1 is x, that means 1 represents my number of hats. So I could say, when I'm describing it, 1 hat, and then 50 is my y, so that's our total cost. So I could say 1 hat costs a total of $50. Now I would want to confirm that either using, again, the graph or the equation. If I go to 1 hat here, it's right there at our 50. And if I were to substitute 1 into this equation, it would say 14 times 1 plus 36, that is in fact 50. So I know for sure 1 hat costs $50. There's one last question here. It says it looks like 120 is on the line, but it's hard to tell. If I go up to the graph, 6 for my x, 120, that's this point right here. And we saw from part A, it is hard to tell. Maybe that's 120, maybe it's 119. How could we check to see if this point is a solution point? How could I check to make sure that point is on the line? Well, I could use this equation here. See if you can use the equation y equals 14x plus 36 to confirm that this point here would be on our graphed line. Well, to do that, it's substitution again. I'm substituting 6 for x and 120 for y, so it would say 120 equals 14 times 6 plus 36. And if this point is on the line, this equation I just wrote should be true. So when I go to do that math, I'm trying to confirm, does that actually equal 120? I would start by doing 14 times 6. That is 84. 84 plus 36 is in fact 120. So because that equation is true, that tells me it is on the line. If I got something not true, like 120 equals 84 plus 30, that's not true, so that would mean it's not on the line. But for this situation, this right here would be our answer. We'll be using stuff like this with substitution and reading graphs to help us answer more questions in today's lesson. Thanks so much for watching.